Hey guys, today we're going to be doing systems of equation. This is officially episode 4 of our multi-episode season where we will be doing algebra, basically teaching you the basics of algebra where you can apply to your schoolwork and get some additional help if you need it. Basically a supplementation course. So we're going to start with systems of equations. We're going to build off the knowledge that we did in episodes 1, 2, and 3. Episode 1, we learned how to solve very simple algebra expressions, which was episode 2, we learned multi-step algebra equations that involve fractions as well. Episode 3, we introduced linear equations, which is in the form of y equals mx plus b being slope-intercept form. And then we have standard form, which is ax plus by is equal to c. And we also taught you guys how to graph and do a little bit of a word problem as well. Today we're going to expand on that, and today instead of solving for one linear equation, we're going to solve for two, as noted here. So these equations are in the standard form of 3x plus 4y equals 20 and x minus 2y equals negative 6. Now, there are numerous ways to solve these, but today I'm going to be teaching you guys the substitution and elimination method. There is also the method of graphing these guys out, but I will not be teaching that today. I might teach it in a later video. Due to time constraints, I will be teaching the fastest, and the best ways, and usually what will come up on assignments and exams. Substitution and the elimination method. So let's get into it. So first, we're going to label this equation 1. Equation 2, so it makes we're going to first do the elimination method. So I'm going to just label it right here. So how the elimination method works is that we're going to eliminate one of these variables entirely. We're just going to eliminate either the x or the y, and then we're going to solve for one of the variables. And then we're going to plug that variable back into one of the two equations, and then we'll be able to solve for the other variable. And I will show you guys how to do it in this first example. So we have 3x and x, 4y and 2y. Right now, we cannot eliminate any of these variables by adding or subtracting because they're all different. So what we have to do is multiply them by a coefficient that will make them the same. So for the first example, we're going to get rid of the x variables. So we got to make the x variables the same. So we have 3x and x. So the easiest way to do this is to multiply the second equation by 3. So let's do that. So let's rewrite the equation. 3x plus 4y equals 20. That stays the same. And now we're going to multiply the second equation by 3. So x is now 3x. And we multiply everything. That's how the rule works. Minus 2y times 3, 6y, equals negative 6 times 3, negative 18. Now our x's are the same. What we're going to do is subtract them. So 3x minus 3x is 0. 4y minus negative 6y, that is going to be 10y. 20 minus negative 18, that is going to be 38. Y is going to equal 38 over 10, or it's going to equal 19 over 5. So that's how we did it. We eliminated the x's and we solved for y. So now we know y is equal to 19 over 5. But we're not done. We solved 1. We got to solve for 2. So we're going to plug it into one of the equations. So we can either plug it into this one up here or this one up here. And we're going to do the second one because it's a little bit easier. It's a little bit less numbers. So let's plug it in. I like to write the steps so it's a bit easier plugging in. So x is the same. So we're plugging in for y. So x minus 2 times 19 over 5 equals negative 6. X minus 38 over 5 is negative 6. X is equal to negative 6 plus 38 over 5. Let's say in the denominator, 30 over 5 plus 38 over 5 equals to 8 over 5. So x is equal to 8 over 5. And typically when you write the solution, you're doing it into an ordered pair. So x comma y is equal to 8 fifths over 19 fifths. And that is your answer. Now, what systems of equations mean? If you visualize this, if you graph these two out, they will form an intersection. And that intersection is this ordered pair. It is the solution. It is the only point. A system of equation, you're basically solving for the one point on the graph where these two linear equations are going to intersect. That is what we're solving for, basically. So I'll just draw an example. It's not to the same equation. So let's say I have one equation going this way and one equation going this way. This intersection point right here would be that ordered pair. So the third way, which I'm not teaching you, is graphing. You can graph these out and you can like roughly know the ordered pair, but I like the substitution elimination method because you can get the exact coordinates. And we can check this answer too. So let's check by plugging in the ordered pair back in. So let's do the first equation now. 3 times 8 over 5 plus 4 times 19 over 5 is equal to 20. So now we have 24 over 5 plus 19 times 4, which is 76 over 5 equals 20. This will equal to 100 over 5 over 20, which is 20 equals 20. Check. So equation 1 works. Now, in order to check it, you have to check both equations because sometimes it'll work for one but not work for the other. So we have 8 over 5, sorry about this, minus 2 times 19 over 5 equals negative 6. So we have 8 over 5 minus 38 over 5. So negative 30 over 5 equals negative 6. And negative 6 equals negative 6. So this is our answer. Boom. That is our first answer. So let's do a second one using the substitution method. We'll do a new problem. So let's do like this. 2x minus 3y is equal to 7. And x plus y is equal to 5. Let's label our equations. Now, the substitution method is also greatly effective. How the substitution method is you take one of these equations and you substitute them in for each other. So basically, for one, I'll show you. So basically, you're going to take one equation, solve for that variable, and substitute it in to the other equation. And then that gives you the y value, and then you just do the last step up here, and you just plug in the y coordinate or the x coordinate, whichever. So we'll solve for the y coordinate. Now we want to make it as easy, so we're going to choose the second equation because it's the simplest one. So we have x plus y equals 5. Let's solve for y. So y is going to stay here. We're going to move the x to the other side by subtracting x. So now we have 5 minus x. And this is technically our third equation. So now we're going to plug 3 into 1. So 2x minus 3. And since this is y equals 3, this will become 3 times 5 minus x equal to 7. 2x minus 15 plus 3x equals 7. 2x plus 3x, 5x. 7 plus 5 is 22. X is equal to 22 over 5. Boom. We just solved for the x coordinate. Sorry. So we just solved for the x coordinate. So here we go. Now, next, really sorry about that. Forgot to put on Do Not Disturb. Now we're going to solve for the y coordinate, and we're just going to plug it in. So we're just going to plug this x coordinate into the second equation up here. X plus y equals 5. X is 22 over 5 plus y equals 5. Y is going to be equal to 5 minus 22 over 5. Now we convert this common denominator. So 5 times 5, 25 over 5 minus 22 over 5. Y is equal to 3 over 5. Bam. So our x coordinate or our answer is 22 over 5, 3 over 5. And that is our answer. And that is the substitution method of this example. And now we're going to do one last example. And this last example is going to be a real world application or a word problem. So I will write out the word problem that I have planned, here we go. Suppose you're running a small business selling two products, A and B. This is a big hint, as like A and B are going to be your variables. You can let A equal X or B equals Y, whatever, or you can keep A and B. I like to keep it in X and Y's because then it reflects the generic examples that we did. So the profit from each unit of product A or X is $2. And the profit from each unit of product B is about $3. We know that selling a total of 10 units of both products combined will generate $24 in profit. Sorry. And that is the thing. So, yeah, that's the problem. So basically, we're going to have to try to combine these. So we're basically going to make our own equation based off of this information. And then we're going to solve for it. So here we go. So let A equal X and B equals Y. So we have the profit. So we know that product A is $2 in profit, product B is $3 in profit, and the total amount of profit that they generate is $24. So we know that it's going to be 2x plus 3y equals 24. Because $2, $3, 24, done. Now we still have this variable, 10 units. So now we got to think about a unit. So we'll just assume it's 1 unit of X, 1 unit of Y, or A and B, which we know selling a total of 10 of this is going to be equal to 24. So X plus Y equals 10. You see what I did there? I grouped the profits into one equation, and I grouped the units. That's how typically word problems will be introduced. You're going to have like two different kind of like keywords. Keyword here is units and profit. So you want to put the profit in one. You don't want to cross them. So now let's solve. Let's solve via the elimination method. So now we have our equations. Now we just got to solve. So let's eliminate y this time. So 3y and y. So we got to make this y 3y as well. So we got to multiply the second equation by 3. So 2x plus 3y equals 24. We did not touch that, but we're multiplying the second one. 3x plus 3y equals 30. So now we can just subtract the 3y's. 3y minus 3y is 0. 2x minus 3x is negative x. And 24 minus 30 is negative 6, which is just x equals 6. That's the first one. So now we got to plug it in. Let's plug it in back into equation 2 because it's easier. The original one, x plus y equals 10. X is 6 plus y equals 10. Y is equal to 4. So our ordered pair is 6, 4. But we got to think in terms of this equation. We got to think of the units. So if we think about the first one, let's go in the second equation. So X, they're going to sell 6 units of product A and 4 units of product B, and which in turn will generate $12 of product A and $12 of profit for product B. So the answer is to get a total of 10 units and to generate $24, we have to sell 6 units of 6 units of A and 4 units of B. You can check this answer if you want to, but if you just do it this one's pretty easy to do in your head, and you can see it's right. So the answer is 6 units of A and 4 units of B will be 10 units total and $24 of profit. I think I forgot to add what the question is asking. The question is asking is what combination will produce this. I'm sorry, I forgot to add that. So, yeah, that's about it for this episode today. Thank you guys for watching. Leave a comment down below if you guys want me to see anything, or if anything in this video is confusing, I can answer it down below. Join the Discord, follow me on Instagram, and catch you guys later. Goodbye.